Alright, greetings. I'm here with another video. Hope you're doing well today. I'm trying to figure out how to program something functional. So I decided I'm going to try either tic-tac-toe or hangman. Something like really simple. So far I did a pretty decent job. I'll show you what I got. Here's the results. Right, so what we have is the title, another header. This is header 2, this is header 1. And then I've got here basically the tic-tac-toe itself. It's comprised of 9 divs. The way I did it was I used grid, and I did display grid, I believe, or grid display. I think it's display grid mode. I don't really see the point of using flexbox at the present moment. I feel like grid is a lot more efficient because then you can create rows and columns using grid row, grid column. So it's very analogous to a matrix. So if I go to, like, I don't know, Wikipedia, linear algebra, right? And I pull up linear algebra, you basically have a matrix, and a matrix is comprised of rows and columns. At least in linear algebra it is two-dimensional matrices. There's more depending on how large your vector space is, but the idea is you have, I think it's D2. D2. Maybe I should write that down. Maybe kind of insightful to draw or paint. Probably not the most efficient approach to programming HTML, CSS, JavaScript, but it seems to be like a more well-rounded approach, in my opinion. And I have reason to believe that if you can integrate your mathematics into your programming as much as possible, you're going to have, in the long term, more effective results, assuming that efficiency and or effectiveness both are based on time. And so here it is. This is basically what I learned. This is like linear algebra condensed into like a few sentences. But basically, you've got, I think it's called dn, and you've got your multiple dimensions. N can be, n is is an integer. So, basically n something like equals 1, 2, 3, comma, dot, comma, n. Something like this. Basically, n equals n. That's the point I'm trying to make here. So depending on what n is, you have different vector spaces. We're working with, our specific example is going to be n equals 2. So in other words, we have a D2. And then now we can work with the matrices. So for D2, in the case of D2, and only for D2, you basically have M and N both. Presumably, what's after N? It would be O. So if it was like, N equals 3, presumably, if N equals 3, I'm assuming you would have M, N, O as your kind of like your components, or I would call them like your legs of your vector space. So right now we've got M and N. There's a lot of ways you can approach this, of course, but this is the approach that that a lot of schools will teach, or something to this degree. And basically, you're working with M and N, and so depending on what your M and N values are, you're going to have certain positions in your matrix. So this information actually doesn't tell us how large our matrix is. All it tells us right now is that it's a two-dimensional matrix, meaning that regardless to how large the matrix is, you define your matrix with brackets, you're going to have basically M x n, right? M cross n. It's not a cross product, you would think, but it's basically like this is the way they abbreviate it. But essentially, M and N are like the informational data points you have to describe your matrix. Now, of course, if you've been to school, and if you've had like a basically pretty universal education in algebra, all of everything I'm saying, todo lo que estoy diciendo es X, Y, ya. That's all I'm saying. X, Y. That's all I'm saying. X and Y. That's all it is. right? Same thing. But in linear algebra, we work with M and N, basically. So, having said that, when you have a grid, display grid in programming, or in this case, in using CSS applied to HTML, we haven't gotten to JavaScript yet. If I use the display grid feature in CSS, maybe it'd be easier if I can add a text, because this is taking too long. Maybe here, add a little text box here, and if I just do display grid, I think the grid would be a different color, right? Let's see what we have in the software. Okay, the display is blue, the grid is purpley. Display is blue, purple for grid. If we have display grid, it's a different font type, so hopefully this is relatively straightforward, relatively insightful. I know that some of us appreciate the type of font we use, and this is not the same font that's being used in the programming language. Maybe I can change it, and it might be easier to remember this way in the long term. Let's see here. Can I select the font type? I can underline, bold. Let's try bolding it. Let's see. Is that any better? Oh, here we go. Calabri. So maybe I can change it to something else. Oh, here we go. Let's do Cascadia Mono. Might be a little better. Okay, that's a little bit better. That's better. There you go. So when we're using display grid, there's two features. So the first one is display grid. That's kind of like the generalized version. You're going to add that to what's called the parent box or the parent div. And then you will then add a feature to the individual child divs that are going to be within the parent div. And so I'll add another text box. We want the same, oh gosh, we want the same, okay, the features are the same, that's good. But basically there is grid, so now that the grid mode is activated, you've got grid column, and then you've got grid row. And hopefully you see where I'm going with this. Technically it's the other way around. Since we're doing M and N, we're doing things in a chronological order. It would be grid row, grid column. In other words, grid row is your M, grid column is your N. And these are basically the kind of informational data points that you'll use to define each, well, what I would call an element within the matrix. In mathematics, I don't know if each number within the matrix is called an element. I know that in a set, a mathematical set, you would call them elements. And when we're dealing with, I believe when you're dealing with divs, I think divs are treated as elements as well. Basically the elemental unit of your HTML file. So for example, the most basic example is 1, 1. You know, so the first, I'm going to keep them as purpley. So it's 1, 1. That's going to be the first one that we have. I guess I'll keep it as some kind of number, but like here, over here, oh gosh. Over here is where I would put, here's where I put the information of that first element. I'll put just a box. Maybe I can put a square there. But like right there, if you can see that, right there, I'm going to put a big old circle around it. Let's add like a circle. But like right there, hopefully there, right on target, right there is where, hopefully in the center of the screen, if you can see that, I am pointing right there. That's basically what 1, 1 is going to look like. And so maybe we can zoom in. We'll zoom in a little bit. There we go. And then I'll use this, and I'll put a little bit of information here. And I'll put it in blue, I guess, even though it doesn't make like logical sense. Oh gosh, we need a smaller font size. I guess 8 is the smallest. It's a little too big. Can I go down to like 3, maybe 4? Let's see. Nope. Go down to 48. I can't go down any smaller than that. All right, so this would be 1. Ooh, it's too big. All right. Alright, so we're definitely going down a little bit of a rabbit hole. Okay, there are the numbers, but like it's a little bit of a rabbit hole, and I wanted to have something that's obviously smaller. So I'm gonna have to delete this. Oh gosh, I don't know if I can. It's backspace. Nope, not backspacing. Alright, getting a little bit of technical resistance. Oh, there we go. I'm going to zoom in here, and I'm just going to have to draw it by hand, but it's one. Oh, there you go. Nice. Look at that. Look at those pixels. That's really cool. Ah, almost a perfect X. I'll try one more time. No, that's even worse. I don't know how I did that. That looked really good. Yeah, I guess something like that. But maybe if I try it one last time, just do. Yeah, oh, that's really close. That's really close. It's probably for the sake of time, I'm going to just leave it there. But basically, it's 1x1. That's what I'm trying to say. And that would be our, basically our grid and row. It's 1x1. And you can keep going like this. So I'll do another example. We'll add another box. This time I'll use the feature here. We're going to draw what I want to be a purple box, and let's see if I can make it a bit thinner because it's too thick right now. Where do I change the thickness of this square? There is some feature here somewhere to make it a little bit thinner. May have to leave it like that for the sake of time. Hopefully it's not too thick. But the idea is, because yeah, that's intense. Anyways, oh man, yeah, I'm now just like I'm going like extra thick now. Like this is whoa. Let's see here. See, I was gonna draw another square, but actually what I want is to draw, just to draw, free draw. Here we go. Oh, it's too thick. There's got to be a way to thin it out. I know there is. I just can't find it at the present moment, and for the sake of time, I would like to be as efficient as I can here. It's too thick. Look at that. Way too thick. I'm just gonna have to go with it. Oh my gosh. Oh, and these are not in the right coordinates. All right, so I guess this will be probably a 4x4 matrix. I kind of have it as a 3x3 at the moment. Maybe I could use the text box here. Let's try that. Oh gosh, so big. All right, let's go down to 8. All right, that's my work. Needs to be smaller. Oh my gosh, it's so small now. Oh, never mind. Anyways, this will be 3x3. Let's change the font a little bit. It's pretty good, but let's try. Ooh, this Castellar looks cool. That looks really cool. Yeah, that might work. Huh, that might work. But we can try more. There's Centaur, Century, really cool names. Constantia, like that. Maybe we try Constantia, let's see. This might work. I might have to, oh gosh. Oh, dang it. It blurred out. That was it, I think. Anyways, hopefully you can see that. It's kind of blurry. It's a little blurry. Oh. Dang it. So for some reason it's blurring out. We're gonna have to try another one, unfortunately. Ooh, let's not use that. There's so many. Oh my gosh. So many. Let's see here. Let's see here. Just gonna try. I might have to go with something like Times New Roman. Kind of a safe bet there. But I'm thinking, ooh, maybe we gotta try Gothic. Ooh. Let's try Gothic Light. Let's see how that goes. Oh, that's not gonna work. Okay, let's just try regular Gothic. They're all gonna be blurry. I think it has something to do with maybe my computer. But for some reason, it's all kind of blurry. Which is a dang shame. Now, where's the thickness on this? It's still too thick. But it's very easy to do. I could draw it by hand. But, No, that's not working. I'm going to draw it by hand here. This is basically 3 by 3. There you go. 3 by 3, right there. 1 by 1, 3 by 3. So, the information of this grid would be grid row 3, grid column 3. And we're going to go back to our previous font, which was Cascadia Code. Here we go. Making the font a little bit larger. Let's go for 10. And we'll make that purple. That purple. Voila, piece of cake. Just like that, we have all the information we have to describe our matrix. So all of this is to describe basically creating some kind of matrix in HTML. Now, the other question I wanted to verify is what are the elements called in a linear algebra matrix? Let's find out. They're called elements. They are called elements. That's good. So there's some consistency there between the different math, computer science, all that. You know, there's a consistency there. That's really good. But here, like, if you don't believe what I'm saying, if you go to Wikipedia matrix, right? You know, here's an example. This is a 2 by 3 matrix. You can see that they call the elements A. I would call them E. I think that would be easier to understand. But they call them A. And then basically, here's an n by n. I would think again, it's m by m. Maybe this n by n over here is says n equals 2. This implies that. Let's see here. Oh my gosh, there's the thickness. Now I can change the thickness. So I couldn't change the thickness with the squares? I guess not. But when it comes to free writing, oh, it's gone again. All right, I clicked on the free draw. No, that's not right. Oh, you got to click on the pencil. All right, this is too thin. We got to thicken that up a bit. This implies, presumably, n by n. That makes more sense. So n by n, what you have will tell you how large your matrix is, right? N by n tells you how large the matrix is. Right. All right, so maybe now I think it's time for a water break. I'll drink some water real quick. I gotta stay hydrated. All right. Okay, so there's more information. I'm just kind of scrolling through. I'm just, again, just kind of like, skipping through the information. But matrices obviously get more complex than that. Another important aspect about understanding linear algebra is that if there's one equation you want to know, it is AX equals B. A being your first matrix, X being some kind of like output of that first matrix, and then B basically being, or excuse me, I messed that up. A is the matrix that you have, X is the variable that each element represents, and then B is going to be your output, basically. And you can manipulate that equation several times. So the manipulation that they had that showed us, oh, here it is AX equals B. And you can see that, it's A is actually a constant in front of the variable, but, I like to call them elements. X is going to be the actual variable itself. So x1, x2, x3, there can be more than one variable if you're dealing with a multivariable equation. And then you have B, which are going to be the outputs, right? So it's a bunch of linear equations. It's your basic algebra, álgebra normal, pero con muchos fórmulas por encima uno del otro. Y todos son lineal. That's the key. They're all linear, right? I'm speaking in Spanish, but what I'm saying is that they're all linear. So again, my audience, presumably those of you who are watching this video are not only Americans, but are people learning English. I think that's the main goal. But I'm also speaking Spanish. It helps me work on both. And so linear algebra grows from there. There's a lot more that you can explore. But I think for the sake of this video and for the sake of what we're working on, that's really as deep as we have to go. Here we go. So I'm going to show you now the code. And so what I did was I basically created a bunch of divs. First of all, I created a larger div, which you can think of it as like a larger matrix. I called it board because it's a board. And then you have a bunch of divs, 9 divs altogether. And you can see that the first one is M1, N1. The second one is M1, N2. The third one is, M1, N3. So that's all going to be the first divs for the first row. Then we move on to the second row, M2 and 1, M2 and 2, M2 and N3. Then finally the third row, I think you get the idea. They're all going to be the same class. I called each one a space because we're playing a game of tic-tac-toe. And so if we're playing tic-tac-toe, right? I mean, it's a very basic game, but if you draw tic-tac-toe on a piece of paper, here we go. You have all these spaces. You can put different objects in the space, either an X or a O, X or O, right? And then just like that, boom, you've won the game. And so the next part that we have to program is the actual like logic of the code itself. This is where it's like this is where I will need your help, basically. Join me as we try to figure out something. I think I will set up a timer, maybe like a 45-minute timer, and see what can we do in this time frame. See how much progress we make, because your guess is as good as mine as far as learning how to program. So I'm going to set up a 45-minute timer. And we'll see how far we can go. I will see if I even have the mental stamina to give it a shot. But this is where I feel like, as a developer, there's a lot of resources that you can approach. There's a lot of methods you can approach. I know that using a book would be the most insightful way to approach. Maybe we start with the book. I'm thinking starting with a book might be the easiest approach, but may not be the most simple approach. And so there's a difference between easy and simplicity. Basically, basically simplicity is the optimal way of doing things. Easy is kind of habitually doing things that are probably more efficient as far as energy goes, energy consumption. But and like mental focus, cognitive endurance would be the term. But ideally, you want to do something optimally that feels easy. I would think that would be the best thing to do. But if you want to have the best results, simplicity is the way to go. That's what I've learned. And so this book, this is Eloquent JavaScript by Marij Haverbeck. I believe it is Creative Commons. So here we go. We were perfectly fine sharing this on a video. Big shout out to this is MIT license, so MIT education. So very good, very good. Excuse me. So as we go, let's see here. We've got introduction, on programming, why languages matter, what is JavaScript, code and what to do with it, overview of this book, typographic conventions. This is probably the next chapter of our video, so I'll put a timestamp here, but the idea is that we're now trying to use the materials that we have to actually create some results. Now this book, the thing about JavaScript, from what I've understood so far, is that people call JavaScript magical. When I look at this book seems to me almost like it's created by a wizard because of the way it's created. You've got values, numbers, strings, unary operations, Boolean values, empty values, automatic type conversion, summary. That seems relatively straightforward. That to me sounds something like an engineer would create. But if you go to the next chapter, right, we got now expressions and statements, bindings, binding names, the environment, functions, console log. Like, why are we learning about the console log on page 39? We should have learned that like page 2. After the introduction, maybe page 7, page 8, something like this. Maybe I would think page 7 by the time you should do that. Maybe I got to write my own JavaScript book. We got to wait and see. But like if I click on control flow, what is control flow? So console log is basically what you output in JavaScript, relatively straightforward. You can use it as a calculator. So math.max 2, 4, it will tell you the max value of presumably this array that's been inserted into that method. And so the result is 4. That's basically, and it gets more complicated than that. So for example, here's another console log, math.min. You got 2, 4. Again, it's going to pick 2 this time because it's the min. The built-in method is basically a type of function. From what I understand, methods are basically functions, but the syntax is different because you do this math.min or something.min. Your math, I believe, is a library of methods, and then min would be the actual method itself. In my mind, I would think that math is a library and min is the function within that library, and that's actually doing some kind of calculation for you. A function, again, is a simple input-output mechanism. So plus 100, and I'll give you 102. Okay, now we got control flow. It says when your program contains more than one statement, the statements are executed as though they were a story from top to bottom. So in other words, when we program, programming languages so far, maybe there's a few that are different, but presumably the bulk of programming languages are actually quite chronological in the way they operate. So they start from top to bottom. The code is read by the computer from the top all the way down to the bottom. Again, it's kind of all two-dimensional in a sense, or actually more like one-dimensional in some analogy. But with the indentations that you're using, right, I would say there's almost like a 2D nature to most programming languages. We're talking about upper-level programming languages. I don't know how the lower-level languages work, like, say, assembly, which is really working more with, I believe, is the motherboard. I don't like that word. I'd rather call it fatherboard. But the point is, there are programming languages that work more closely with the binary nature of a computer, the way the computer is actually processing information, as opposed to the upper level languages, which are really more for us human beings to give the computer specific inputs, right? So let's see if I can find something on upper and lower level programming languages and see if we can, here's a matrix of them, interestingly enough. Let's see what's that about. I wouldn't think it's a matrix. I would think if it's a matrix, it's a 1 by something matrix because it's going to be one row from top to bottom, or rather, maybe a better analogy here is a matrix with one column, top to bottom, and it would show you the programming languages. So, for example, I'm still relatively new at this. There's no need to say that, but I'm going to say it anyways. So that was as an example of me speaking easily. But like I would think, programming languages, LNG. These are abbreviations. And I would think at the top, you would have something like, say, JavaScript, right? Or maybe Python. Okay, so this would not be a 1. This would be maybe, well, actually, you can treat each element as its own matrix, or rather its own array. So this would actually be technically an array. But the point is, it's one row. This is still like 1, 1, right? But I'm going to erase this. We need a little bit more space. Go back to the pencil. Thickness is good. 1, 1. There you go. So that would be actually one element of this 1 by 1 matrix. This is actually an array, but arrays are similar to sets, and which have, in some sense, they're similar to matrices in that they're all objects. I think in computer science they would all be called data structures. Now I could be mistaken on that. There is a whole coursework focused on data structures at university, but when you look at the word data structure, we're talking about structures of data, and the most universal way that data is formed is in packets, right? And these are all kind of packages of information, except they happen to be stored in a very organized way, columns and rows, basically. I mean, all this could be analogous to Excel, right? Right, all of this is basically what Excel is doing on some level. So, anyways, there may be other programming languages here, but I think eventually you're going to get to one called assembly, which is a little bit lower. And it'd be kind of interesting to maybe see pictures of what assembly actually looks like. But then we go a little bit lower, much lower. And I think eventually the last one is binary code. I could be mistaken on this, but please comment questions below. Please verify this information for me, please. Provide some feedback to let me know if this is correct or not. Be very useful to your learning process. So, anyways, let's see assembly. An example of assembly code. Here we go. Let's see how it looks like. Maybe we can try to read the syntax a bit, see if we can get any clues as to how the language actually works, and how the functions in that language work, to see if it even has functions, right? I doubt it does, but maybe it does. This is loading. Elevator music. Let's see if we can find another picture. Yeah, this is taking too long to load. See this picture. Maybe take all too long to load. You guys and gals may not be able to see what I am looking at when I look at these images, but I can tell you now that I am not going to be fully able to understand how this programming language actually works. Here we go. So there's something called directives. There's start and loop. So it does have loops. Oh, here's another image. Oh man, this one's kind of blurry. Can't even zoom in on it. But yeah, here we go. Labels or something called loop. Examples of a program which generates a sequence of pulses with a frequency of 1 kilohertz. The output pin is 0.0.1. Quartz crystals, 12 megahertz. So, I mean, at least we're getting information on hertz, and hertz are actually frequencies. So it might be information on the frequency of like some kind of electrical signal that's going into or out of whatever this programming language is measuring. When writing a programming language and assembly language, it is necessary to observe specific rules in order to enable the process of compiling into executable hex code to run without errors. These compulsory rules are called syntax, and there are only several of them. Every program line may consist of a maximum 255 characters. I would think it's 256. Every programming line to be compiled must start with a symbol labeled mnemonics or directive. Interesting. Text following the mark in a program, a line represents a comment ignored by the assembler. Okay, there's comments. All elements of one program line must be separated by at least one space character. Okay. There's also numbers. There's decimals. Obviously, so we are working with decimals, 0 through 9, all 10 digits. That's useful to know. There are 16 digits in hexadecimal number system. So we got 0 through 9, and then we got A, B, C, D, E. Interesting, all in caps. The largest hexadecimal number can be written in assembly language as FFF. Interesting. So that actually is actually a binary syntax, I'm presuming, or something having to do with binary. Binary numbers can also be created. There are only 2 digits in use, 0 and 1. So in other words, assembly, what we're gathering here is that assembly is not the bottom. It's not the bottom of the well here as far as programming languages go. It's somewhere stacked. It's not necessarily like a call stack, but it may have some analogy there. But the idea is, we've got these upper level programming languages, which is what's most common these days when people think of coding and people think of programming. But the reality, or not the reality, but the nature of computer science in the history of computer science is such that the languages have been around. There's been languages that have been around far longer than, say, JavaScript. I mean, JavaScript has existed since, I think, the 90s. Basically when the internet was formed, right? They played a really big part in forming the internet, but the languages go further back than that. So the point is here that we're trying to simply understand a system of how the computer languages are structured. So anyways, here is a matrix. We've got upper triangular algorithm, a lower triangular algorithm, storage optimization, LU decomposition, solving equations, determinants, transpositions, multiplication. I don't believe this is actually what I mean by upper and lower level programming matrices. This is more of like a universal definition of what a matrix is and maybe how it's defined in programming languages. But let me see if I can say, like, call it a map maybe. There's other mathematics that we can use to model how programming languages work. But yeah, here we go. Here's somewhat of an example. We got Python, R, JavaScript as high-level languages. And then low-level languages, we've got C and Fortran. So Fortran is a little bit lower, a little bit deeper than, say, Python, R, or JavaScript. That's interesting. Programmer, high-level language, assembly language. There you go. And then machine language. We're not speaking about machine learning, to be clear. We're speaking about machine language. So, maybe I would think that machine learning then is like, that is basically what's stacked on top of high-level language. Something like this. And that's where the programmer is, and maybe that's what the future of programming may look like. Because a lot of people seem to be really, really, really excited about like trying to create a future where you don't have to code, which sounds ridiculous to me. This is a really nice image. Let's save this, and maybe I can come back to this. We'll call it M1. I'll call it MN N1 programming languages. There you go. And then we'll create a new file. I'm going to paste the image that we have. Here we go. Now we're still going down the rabbit hole. We're not in Wonderland yet, but we are definitely in the rabbit hole. And this image, which is a little blurry, it's not the best image. But basically, we've got programmer, high-level language, assembly language, and machine language. And I think I'm going to have to create it manually here because it's so blurry. Programmer. Let's see. I'm going to delete this image. I think I got it. So let's go here. I'm going to do in caps so you guys can see, or maybe I increase the font size. It doesn't have to be in all caps. It's ridiculous. Let's do maybe like 2022. One of these two. Let's just leave it at 24. Programmer. Next was high-level language. I'm going to have to look at my notes. High-level language. High-level language. I guess we are doing caps. Then we've got, what's after that? Assembly language. And then finally, what we have is machine language. All right. So this font size is too large. I'm going to reduce this down to maybe a 10. No. 14. Also a little small. 16. Not bad. All right, so what I'm predicting, this is kind of my prediction, speaking as one computer scientist to another. What I'm predicting is that basically, or what I'm understanding, what I'm exploring, studying, analyzing, is that machine learning is basically going to be here. It's going to be here. We're kind of running out of space right now. But it's like I want this diagram to be clear. Very, very, very clear. Maybe we got to use boxes to kind of make the point a little bit clearer. I know that for other programmers this would make like a lot of good sense, right? But since my audience may not be like people who are thinking, completely technically, I'm thinking that maybe, we got to create like boxes here. But basically, machine learning would go in this box. There you go. Machine learning would be one. Then we would have the next box, which basically has program. I mean, I'm going to actually insert it as one other alternative box because this is basically what we have at the present moment. I'll mark it as blue, but it should be probably more like purple. But, I would say it's blue. Present moment. And then basically all of this is the current, I guess I'll put this in purple. Current programming, current computer science system of a system of programming language levels, right? And this would include the programmer. This would include the high, maybe we got to turn off the caps, high level language. Let's see here, we got any more high level language, right? After that, you've got assembly, and then you got machine learning, right? So I'll do assembly, assembly. I'll just keep that as an abbreviation, and then we got the machine language, right? Which is, in other words, basically binary. Parentheses. There you go, ML, to add clarity to what we're getting at here. All right, but machine learning is, from what I understand, the best analogy for machine learning is that in programming or in coding, you give the computer clear instructions. The programmer creates commands, and then you give the computer will interpret those commands. Well, in machine learning, it's the opposite. The computer will receive information, and then based on that information, will create commands, something like this. That's the analogy, but there's another way to interpret it. I would have to look into my notes to tell you exactly what I mean by that. It might take some time, but I believe it's going to be insightful for this video. See if I can find it in a timely fashion. But you basically, yeah, you got unsupervised and supervised learning. That's another part of machine learning. Let's see here. No, I have to go deeper into my notes to give you the exact information that I'm looking for. If I don't have time, I mean, I'll give myself, we're on a time limit. How are we doing on time, by the way? Time is actually going by quite fast. It's already been 20 minutes. But like, that doesn't make sense what I said, right? Like, how is it that a computer receives information, but then in regular programming, so like, I'll say PC receives info, right? Versus the opposite of that, which is more like info receives PC. Does that make sense? Information receives the PC. So I think maybe another way to say it is that PC receives information, algorithms create output, while in machine learning, output creates algorithms. That might be the better analogy here. Output or output slash input receives or output input. These are like, this is the command prompt. This is the command prompt that I'm speaking about. Command prompt. I'm running out of space again. Command output slash input, which is the command prompt, right? Which is pretty like common for programming languages. Receives output slash input, while the in machine learning, what you get is the the output input command prompt creates algorithms, right? You're building algorithms for the computer, or excuse me, algorithms create outputs, right? I think we got it now. Output inputs. Actually, it'd be algorithms create outputs. We'll leave it at outputs. Algorithms, right? So for example, the algorithm of tic-tac-toe creates, hopefully, I hope this is useful if you are colorblind. Hope you can still see the color differences. But this is one color. Maybe I'll put a star here. I cannot go and change the text box here, but I'll put another star there. These are the same color types, while this up here is a specific symbol or kind of like category. I think I'll put a pound symbol there, and then down here put the pound symbol again, and basically what we have is algorithms. Tic-tac-toe will create outputs. That is the original nature of computer science. It's been around for a very long time, since the days of Turing, right? And even before that. But what we have now is in machine learning is that outputs, or technically inputs, But outputs, another way to say is data creates algorithms. Algorithms. So hopefully you can hear me well and you can see this clearly. I'll zoom in a little bit just to make the point, just get the point. But this is what we have in machine learning right now. Machine learning algorithms, tic-tac-toe will create outputs, right? Certain, very linear or rather very chronological algorithm will give you a specific output. In this case, a game like tic-tac-toe. While the machine learning specific outputs or data that you feed the model will give you certain algorithms. That's sort of more or less what we're kind of going for as far as this process. For now, what we're dealing with is the purple. We're dealing with the purple mode. We're dealing with the original programming language. I believe there's still a lot of great value in learning this. So, join me on this journey. If you made it so far, definitely give it a like and favorite emoji. All right, so what more can we say? Let's get back to the purple, or in this case, the star mode, and let's try to figure out how we can now modify, let's see here, this box here, how to actually like click and select these boxes, right? Now, I could ask ChatGPT or any of the other chatbot models to tell me exactly how to do it. That would probably be the wisest thing to do, I would think, and probably the most efficient approach given just the nature of technology these days. But I feel like as a computer scientist, it's still very valuable to know how the fundamentals work. So, if you have any insights on what's the best methodology here, should I prioritize effectiveness, which would obviously be using the chatbot models to give me feedback, or should I focus more on efficiency? May not even be like this. Which I would think in the long term is about learning the very nature of every logical step that we apply and learning the essence of logic. Now, if we look at this book, The Eloquent JavaScript, they're talking about control flow. I think the idea here is to look at the book and see if we can get any information that can maybe teach us how JavaScript actually works. So here it says something called conditional execution. Conditional execution is created with the if keyword in JavaScript. So they're talking about conditional statements. Again, I don't know why they call it execution, but basically your standard if-else statements. So again, this video, and I think I have to put it in my video description. But my audience, I'm presuming, are people who have been stuck in basically what's called programming or tutorial. There's a name for it, but basically, if you've been taking a lot of tutorial courses, but you still haven't actually programmed, this is for you. With and do loops, while and do loops. This is for us, right? For you and me. While and do loops, a little bit different structure. Here's a while loop. Very nice that they have actual images describing how it works. Then there's indenting code. Basically, indented code is like a sandwich that belongs. It's the slices that fit into a bigger sandwich. Then we have for loops. For loops, let's see here. For loops, a different type of loop, not like the ones in assembly. Then you can break out of a loop, you add break. Okay, we got that. So this is all kind of teaching us the syntax of JavaScript. Updating bindings, I'm not sure what a binding is. So I'm going to go ahead and skip that for now. Dispatching on a value with a switch. A switch is basically another type of if-else statement. It's the same thing, just a different syntax. Capitalization, just basically another syntax way of describing your variables. Maybe that's more of a diction. Syntax versus diction. I think syntax is structure, or diction is structure. I think syntax may be the type of letters you choose. Let's find out. Diction versus syntax. Let's see. Because everybody talks about syntax in computer science, but they don't actually talk about the difference of the diction in programming. Diction refers to a specific choice of words and phrases or writer uses to convey tone and meaning. Syntax refers to the arrangement, order, and structure of those words. Okay, so on that note, this is obviously going to be an example of diction right here. That's good to know. We are learning a language after all. Then there's comments. Basically you're commenting your code. Summary, we're not going to read that. I've pretty much summarized it already. Fuzzbuzz, write a program that uses console log to print all the numbers from 1 to 100 with 2 exceptions. For numbers divisible by 3, print fizz instead of the number, and 4 numbers divisible by 5 and not 3, print buzz. So that's actually quite a tricky programming language to create. And then here we can also write a chessboard, write a program that creates a string that represents an 8x8 grid using new line characters to separate lines. At each position of the grid, there's either a space or a pound symbol. So this is really where computer science deviates a great deal from mathematics, because in mathematics, you're not really focusing so much on, I don't think you're really focusing on algorithms as much, but this is about understanding algorithms. Now, I know that some of you either have the experience to do a really great job at creating algorithms. So if you go on Code Wars or Elite Code, I know is the big one for like interview jobs and things like this. Obviously you want to get really good at that. That's not the current style that I'm using to learn programming. So, because I find myself being stuck on those problems for hours and like having no idea how to do it. And so something tells me that there's a more efficient approach to learning how to program, and we can kind of get around those. But we should definitely try to understand some of those eventually. We'll see. We'll have to wait and see. But there's functions. So we talked about functions, basically input and output. This is the input right there. And then this is the output, basically. Now the syntax is a little odd, but it's still input output because, again, we're talking about things that are operating in a linear way. I think for a lot of this information too, you may have to slow it down because I know I'm talking very, very, very quickly, but hopefully you're able to catch up. My advice for learning this information is don't be like too hyper focused on it. Just be with me and being efficient, effective, going with the flow kind of thing. We're not like working on something very, very specific at the present moment. Not exactly. This is a more systematic approach, not necessarily a technical approach, although it is technical in nature. So then anyways, we've got binding and scopes. Let's see, each binding has a scope, which is part of the program in which the binding is visible. I'm going to move on from that. Something having to do with scale. Nested scope, that's where the scaling comes in. Okay, we're moving on. Functions as values, that's interesting. Okay, so yeah, pretty straightforward. You can call a variable and assign a function to a variable. Relatively straightforward. Declaration notation, not sure what they're talking about. I'm looking at the code. It looks the same to me, so I'm moving on. Arrow functions, just another way to write the same thing. So that's just like one of the specialties of JavaScript, is that it likes to have a variety of syntax. But, again, the logic is the same. And I think for the sake of programming, it's up to you to decide which syntax style you use, as long as the logic is consistent and if you have just quality code. I know that, it's a big thing right now. It's having good quality code that is functional, that is efficient, that's saving computer power, and so forth. So that's something to work on in the long term. Now we have the call stack. The way controls flows through function is somewhat involved. Let's take a closer look at it. Here's a simple program that makes a few functions call. A run through this program goes roughly like this: the call, blah, blah, blah. We could show the flow, not blah, blah, blah to the writer, no disrespect, but respectfully, we are looking for a way to be, again, easy flow. But let's see here. They're talking about the call stack. This doesn't look like the call stack to me at all, from what I've heard. So we're going to carry on. Our goal is just to go through this book and see if we can find anything useful for our particular project. Now, I wanted to finish this project in 45 minutes for the sake of the video, but we have 10 minutes left before our timer runs out, so I don't think we're going to finish it in 10 minutes. There's closures, not recursion, but closure. The ability to treat functions as values combined with the fact that local bindings are recreated every time a function is called brings an interesting question. What happens to local bindings when the function call that created them is no longer active? The following code shows an example of this. It defines a function wrap value that creates a local binding. It then returns a function that accesses and returns this local binding. So they're talking about binding. I'll tell you now, I still don't know what binding means exactly. We've been through this book now for at least 20 minutes, and they've mentioned it probably like 5 times already, and they have not really clearly told us what binding is, and it hasn't revealed itself in a clear way. So I know that scoping is the scaling, but binding, I mean, I would think that the term binding is to simply assigning a variable some kind of value, but because you're binding it to a value. But that's my best guess. Recursion. So recursion is a different type of like reiterating. Basically, it's a function that basically like operates on itself. So for example, here you got power, right? There's the power, that's the name of the function. And you can see that within the function, there's power again. And so you basically, the function will repeat itself several times until a certain condition is met, which is this if condition, right? If exponent equals 0, and you can see that the exponent value is going to be changing over time. And so the idea is that you can, it seems to be an efficient approach. It works with a call stack. And the idea is that basically the function will keep iterating itself until a certain condition is met. And once that condition is met, it will go back and finish executing the remaining incomplete functions. So I feel like a good analogy here might be like mirrors on mirrors, which I know that in cinema, there's a term for it. There's a term, as a French term when watching film. But like I feel like the analogy here is kind of like what this guy's doing here. Although his hands are a bit distracting. Let's see if we can find a more gentler picture. The idea is mirrors on mirrors. None of that. None of that right now. Not really seeing it. This is actually kind of interesting here with the cube. But let's see. Mirrors on mirrors. Mirrors on mirrors. 2 mirrors. Let's see if we get anything that kind of shows this horror film. Great. Great. That's exactly what we're looking for. Okay, this is actually a pretty cool example here because it reminds us of Portal, which is a really cool game. Really cool game. But look at that. There's 2 mirrors, and you can see that all you need is 2 mirrors, and you create this like unlimited mirror effect, right? You get this unlimited mirror effect, right? And that's kind of in a sense what's going on with recursion in some way. And it's like once you meet a certain condition, the doubling effect or the infinite effect, the repeating effect will stop, and then you'll go back and kind of like hop through each portal, until you've hopped through all the portals effectively, and then presumably the portal will close, or in other words, the function will shut down. So that is really neat. Good job. That was really cool. Good article. Awesome. I'll put this article in the video because it'll be, oh, look, there's another example. This is what I was looking for too. This guy has a picture. He knows, he gets it. Nothing about physics. Not exactly, no. It could be. I mean, if that would be more of like a applied computer science. But I think this portal analogy is really good. So if you're interested, if you're more curious about this, what happens if you put 2 mirrors opposite to each other and you want to kind of get into the physics, I'll put the article down below. It might help you kind of tighten your kind of ability to connect the dots, essentially. Something like this. So let's keep going through this book. Recursion, closure, call stack, these are all kind of like advanced programming concepts. Then there's also like what's it called, not open source functions, but like full stack functions. There's a term for it. Multi-stack functions, there's a term, but basically you have ways of functions operating on functions, from what I understand. So all that's pretty interesting. but like we're not going to dive too deep into this just in one go. I think it's easier. Let's see how we're doing on time. 4 minutes left. So data structures and objects arrays. So data structures are basically talking about objects in arrays. Objects are, in other words, objects are another type of data set or data type. It's another type of data structure, but they're analogous to what we've talked about already, which are basically sets, matrices, arrays that are similar. But they're not exactly identical. They have a few special rules here and there. Here's where the magical part of JavaScript enters the picture. We have the where squirrel. What are they even talking about? We may come back to this another time. Then there's data set. So boom, there you go. That's a standard array. Console log. You can print. This is a syntax printing out specific values within the array. And then we've got properties. I believe properties apply to objects more so than arrays. Then we got the methods. We've kind of briefly mentioned how methods work, but like to uppercase is a function, right, that comes from a library called doe. Or maybe doe is not necessarily a library, but it's a variable, which is what's going on up here. Kind of interesting there. But we're going to keep flowing. They talk about objects. We haven't talked about objects in this video, and we're not working with objects. At least I don't think we have to. But maybe, there's a whole nother side of programming called object-oriented programming. Maybe we come back to this tic-tac-toe project, and we try it again using, object-oriented programming. Multibility, mutability. Don't know what the term is, but we'll come back to it. We're not even halfway through the book. And you can tell that this JavaScript book is already quite deep. Right, and it just goes to show you how deep of a language JavaScript is, or any programming language is for that matter. Eventually, we can talk about HTTP, which is helping you build a browser, or rather, yeah, I think it's a browser. So there's, security in HTTP, form fields. Not sure what that is. This looks to me a little bit more like HTML right here, right? Because the P are paragraphs. This is input, this is type, this is value. This is HTML. What we have here is HTML. There it is. This file is created with this HTML code, and this is the actual output that you get. So nice. Now we actually are talking about building a website, which is actually going to be pretty useful to do nowadays if you want to, be a programmer. Definitely a cool thing to check out. So we will come to this, but we got to stay focused. Actually, this is more or less what I'm looking for right now, is learning how to integrate JavaScript into HTML. And so right now, this is what I have in my code. We can see here we got a script, and the script basically is called the DOM, which is Document Object Model, and it's basically, technically, it is there's a term for it. It's not a tree. But it's actually some kind of data structure that converts all of the information, all of the data in HTML into a data structure that then can be read by JavaScript. So it's actually pretty neat. Very simple approach, but a very effective approach. Let's see if I can find a picture that is helpful. Again, if this video has been really valuable to you and it's actually helping you learn how to program and think like a programmer, definitely give it a solid like. Big old like, subscribe if it's helping, stay tuned for more videos, but the idea is that you are gaining some kind of learning value from this video as much as I'm able to explain it. But here, this is how the document object model works. This is awesome, by the way. Thank you for listening. This is helping me a ton. So thank you for listening and actually learning about computer science and learning about something technical essentially. So anyways, here's the DOM tree example. You can see that HTML is kind of the first layer of this tree. So it is a tree. When they mean by tree, they're really talking about just like something that has like basically some kind of structure to it. So, you've got HTML, you've got a header, which is another element. Technically, it's all elements. It's like elements on elements. It's like you could use matrices on matrices, right? The idea is that this could all be modeled with linear algebra. This is the point. A tree can be modeled with linear algebra. Oh, so there's my alarm. So I think, this video is getting pretty long already. Definitely let me know if I should make this video into one part or two parts. Because we're not done yet. Because I know that some of us, like the focus thing is a challenge. So I'm thinking, do we take a break and come back, or do we stay locked in and we just keep pushing until we get the results that we're looking for? And something's telling me that the most effective approach, even if it's not the most efficient, is to keep pushing forward until we get some results. And I think we may get an optimal result within a limited time span. So it might be a little bit longer, maybe another hour. Who knows? I'll set another timer for 45 minutes. Maybe the wisest thing to do here is another water break. So let's go ahead and do that. I gotta use the bathroom, so I'm not that thirsty, but I'll drink some water. If you got water, this is a good time to drink. All right. So we got the DOM tree example. Basically, we've got elements on elements. We've got matrices on matrices. I mean, if you've got a 1x1 matrix, you've got a matrix with one element in it, right? So maybe what I can do here is I'm going to copy the image. And then what I'm going to do is save this image here. These are my notes, by the way. I got to look at these notes later. I should call this ML to basically modern programming, modem programming. That's funny. Let's save this. I'm going to create a new image, and I'm going to post this image into that image, or post this image into this blank page. And what I'm going to do, make it a little bigger. There we go. That's better. What we're going to do is we're going to get the pencil, and we're going to just put little brackets around them. And this is a 1x1 matrix. They're all matrices. Isn't that cool? Another matrix. Another matrix. Now, I'm not going to say these are 1x1 necessarily, but the HTML actually is not a... Is it a 1x1? I guess this would actually... HTML would actually technically be a 1x2 matrix, because you got the header and the body inside that matrix, right? They would go inside there. The header here in this example would actually be a 1x3, because it's got the meta, link, and title, which are each elements, right, inside. So these are not matrices, right? These are elements, so they don't have to be bracketed. But this body here actually has, this is actually would be a 1x2. Actually, I'm doing it wrong, folks. I'm saying one row and it's 2 columns, but it's actually going to be 2 columns in one row. No, we're doing fine. It's one. Oh no, 2 columns. What the? 2 columns? No, it's not 2 columns. It's gonna be 2 rows. So let's get rid of all this. Oh gosh. Okay, put this back. I'm gonna change this to a 2 over here, like so. It's a 2. It's gonna be 2 rows, because it's a chronological. Again, the code is being read going down. Code is read chronologically. Chronologically. Going down. Like that. Okay? Going down. Alright, so you can see here. Let's see here. We got the header. This header in particular has 4. So I can add some comments. Let's see if we can add some comments in HTML. There we go. I'm going to say this is going to be M4 and 1. Like that. So then you got 4. Yeah, you've got 4. You've got 4. What should I call it? 4 rows, but 1 column. M4 cross N1. Then you've got the body. All right, are you with me so far? Do you copy? This one, you've got H1, you've got a div, and then the script. So that's 1, 2, 3, 4, like so. Also M4 cross N1. All right. That's pretty good. I'm going to save this. Nice. Saved. How we're doing? We're doing well. Let's see here. I'm going to go back to this drawing that we have here and try to simply use what we have in the picture here, which is technically different than our own dome tree that we have in our own program that we're currently building for tic-tac-toe. I want that to be very clear. This is not the one that we're working on. This is the one that we have as an analogy. It's another analogy. It would be useful to build it, of course, from scratch, but for the sake of time, because of time, we want to simply be efficient here. So anyways, this is a 2x1 matrix. So this one is M2 cross 1. This is going to be a M3 cross 1. I'm just going to simply call it 3 cross 1 to stick to the linear algebra formula. But you could also call it, if you want to be like specific, it could be 3 cross 1 slash M3 cross N1, which is what I have in the notes, in the comments rather, which are technically notes in the syntax of our programming language. This one here is actually going to be a 2x1 slash M2 cross N1. And then we're not done yet. This one is actually also a matrix. Finally, we have our first 1x1 matrix. M1, N1. Our div here is also another matrix. This is going to be 1 cross 1 as well. And then the strong actually is another matrix with its own element. This is also going to be a matrix here. 1 cross 1. Or slash, M1 cross N1. Right, I'm sticking to, I'm trying to like create some ideal kind of universal logic here, if this is making sense. But it's not Ionos, it's Chronos. Oh, dang it. But anyways, there's another brand, check them out. But what we're actually working on here is Chronos. Okay? So, let's see. So hopefully I set the new timer, and so this video obviously is going to be long, but again, the goal is to simply work with the script so that we can click and select, basically make these objects, make these elements inside of our divs, which are called spaces, which are actually elements of a larger matrix, but everything is technically an object, but it's not object-oriented programming. The idea is that we can basically open up our code, and where is it? Here we go. And we can just click, and this will disappear every time I click. And I think, for the sake of time, we'll click and just make these things disappear. So we got to obviously create some sort of command using JavaScript to command these things to click in and click off, disappear, appear, disappear, appear, disappear, that kind of thing. So, going back to the book that we had, this is not it. Where it is. We're getting closer. We're getting warmer to what we're looking for. So anyways, they have the DOM. They're using the document object model approach. And basically it's going to select a particular element. So this one is called document query selector. This is a method. from DOM, presumably, and it's called input, and it dot focuses. So it's like a method on a method, a function operating on a function, something like this. And they start to combine together to create a specific command for your program. So if we go back to that other picture I had, again, it was the star pound or purple black. The information there was suggesting that in machine learning, you in standard programming, you have commands that create an algorithm. Is that true? No, you have an algorithmic command that creates certain outputs, but in machine learning, you have certain inputs that create a specific algorithm. Presumably, that would imply that it also creates a certain kind of command. Maybe perhaps in when you are online and you're searching for anything, the what's the term? The algorithms suggestions that you get on the internet are based on some kind of algorithm, and you can interpret it as some kind of command or some kind of suggestion, or better yet, implication. And so it's some kind of implication, you know. And this is how basically marketing works on the internet, So this is how the YouTube algorithm works, suggestions. This is how shopping works when you're buying products, so on and so forth. There is obviously an incentive there. And the main incentive is like essentially capitalist model, right? Because money is the most valuable commodity in capitalism, supposedly. I don't think that's true. I have reason to believe that the most valuable commodity in capitalism or any kind of social system is about building some kind of tool that is of use to another human being, or building something that is of use to another human being. So it could be a car, like the T model car built by Henry Ford. I think it was in like 1905 or something like this. I think, yeah, 1905. We can verify this real quick. Henry Ford's T model. This is coffee break. If you got coffee, now is the time to drink it. Henry Ford T model. What is it? Was it T model built? In 1908, not 1905. But I think you must have been prototyping it at least around that time, right? Let's see. Let's see what we get information on 1905 here. Because there was something going on in 1905 that had to do with some kind of advanced technology. The Ford model was not built in 1945. The first production was built on October 8th. Okay, 1905 context. In 1905, Ford was producing the Model F. And working on the lighter, more affordable Model N, which served as a precursor to the Model T. Okay, so he was working on models, but he was working on the Model F in 1905. Let's check it out. Let's just see that. Model F T model. Let's see if we can get, okay. Not exactly what I was looking for. Model F car. Let's see here. Loading. Oh, okay. That's kind of cool. Damn, that's hot. Look at that. Nice. Look at that Ford Model F. Wow. So fucking. I mean, look at the curves on this Ford Model F. Nice. All right. This is cool. That's a nice car. I'm sure. I mean, some of these cars are still working today. That's actually pretty neat. Hey, that's pretty neat. All right, and let's look at the T model, just respectfully. Be nice to see the T model as well. Oh gosh, it's loading here. Oh, there we go. All right, so yeah, this one definitely has got a lot more utility. I mean, you can tell, like, this thing you can take that baby off road, right? You can, maybe not off road, but you can drive it down, at least like a rocky road, that's a nice. Oh, look at that, 1927. Nice. Yeah, I'll drive that car. I wonder how the transmission works in a car like that. How do you even start the car? You gotta like spin the front part, right? That's pretty cool. So anywho, you can tell that the Model F not as robust as the Model T, right? And I think the Model T had a lot more utility to it. It was not so much a luxury car as the previous models were. It was more designed for mass production effectively. So that's really interesting. And it was also designed to work. So that's really, really, really cool. But yeah, model Ford was, you know, doing a really impressive job at the time. So if we go back here, let's see, where were we? We got here. Okay. So, anyways, hopefully this is making sense for your kind of like cognitive capability. So, with that said, let's look at what this is doing. Query selector. Not sure what query selector actually does. So supposedly it selects any of the elements, maybe. And then there's a console log, document.activeElement.need.tag name. Okay, we're getting warmer. Query selector input.blur, document active element.tag name. Input type equals text, tab index equals 1. Not sure what's going on here. Bottom on click equals console.log. Okay. Okay. Tab index equals 2. Okay. Button. So this is a button click. Button on click console log. Okay. So presumably you click on a button. A button's another type of div. On click, there's a console log that says okay, but then there's a tab index 2 that says okay as well. Not sure what the tab index is, but presumably you console log, you click the button and I think it console logs okay in your command prompt. Something like, your command prompt basically, which is another area of programming, so command prompt, here we go. This is the command prompt, and so you would get outputs with your JavaScript basically. That's what I'm understanding. So disabled fields, not sure what's going on here. Maybe you can disable and activate some kind of button. I'm all right. Form as a whole. When a field is contained in a form element, its DOM element will have a form property linking back to the form's DOM element. When a field is contained in a form element, its DOM element will have a form property linking back to the form's DOM element. No, they're going to have to say that in another language because I don't understand what they're saying. I don't see the logic here. Its DOM element will have a form property linking back to the form's DOM element. I'm going to read that one more time. When a field is contained in a form element, its DOM element will have a form property linking it back to the form's DOM element. Duh. Every DOM element links back to an HTML element, regardless if it's form or not. So here's form action, name, password. Okay. Script, let form equal document.query selector form. So presumably when you have form in quotation marks, it's actually going to the name of that element. That's what I'm assuming, right? This form in quotation marks is this form up here. So it's the HTML form, and you're calling it form again, but this time it's a JavaScript variable. I believe that's what's going on here, which actually starts to make a little bit more sense. My gosh. All right. So let form equal document query selector form. Another way to select the element, I would think they should call that element selector, not query selector, because your elements are not your query. Again, this is where you get into the finicky quote unquote magic of programming languages like HTML, like CSS, like JavaScript, because they were created in a particular way. There was obviously a logic to it, but I don't know if it was in long term, the most uh, hmm, maybe it may not have been the most simple approach. I have reason to believe. So, anyways, we have document query selector. We have text area dot add event listener. We have add event listener. Okay, this might be what we're looking for. Okay, so this variable called text area is attached. This JavaScript variable is attached via the DOM to text area, the HTML element. So maybe it's useful to have another drawing. It's like I don't want to keep opening up new and new documents like this. But I think, you can call me professor. And DOM tree example, yeah, I think since I'm basically like, I don't know, you can call me like mentee or mentor, whichever one you prefer. But the idea is that we are maybe not pair programming, because pair would be like some kind of like collinear. I would say it's more like, maybe like level programming, and it's like, it's more vertical, if that makes sense. So as far as this goes, text area. Yes. So basically, we've got a HTML element. Under HTML, probably should change the color here, but I think the colors are okay. HTML element, it basically goes to the not domain, but DOM model, which again is a tree, some kind of tree here, like so. Again, we got those matrices that are kind of working on, but it's translating all of these elements, which are actually have brackets. Right, these would be brackets. And so the DOM is kind of like the method or set of methods, or its library of methods. I mean, it is basically a bunch of methods. So the syntax would be like dot method. I'm going to have to keep certain things short here just to keep things efficient. Okay, and then over here, we've got let's keep it a little friendly. Method. Let's call it method. There you go. That's better. Okay, so we've got method, which is the DOM over here. This is the DOM. Okay, the DOM. And then over here, what we have is the JavaScript. Yes, I think the JavaScript, respectfully, it's gonna be nice, gonna be like a red, like so. All right, so that's JavaScript. And then the results are the following. Let's see here. Over here, you got a variable, right? So the variable would be called let L. Like so. Let L. Element. Well, we'll call it L because we got L over here. These are abbreviations. There's no period over here, and there's no period over there, because I don't think the syntax would actually work. But this should work if you plug it in. So if I want to be like super precise, super universal here, I'd do that. Just cross those out. So you got method and you've got DOM, right? And then what else we got here? This is looking good. This will communicate to that via the DOM. I feel like the DOM should be blue. Let's do this again. DOM is more blue. There you go. DOM is more blue. And so this connects to that via the DOM. Right? Blue arrows? Maybe. Maybe we can do like, let's see here. I might try something like this. Maybe something like that. The idea is this is actually another type of mathematics, which is called category theory. Category theory is, the best color for category theory is maroon. But this would be basically one category right here. Then you've got a arrow. Then you've got another category over here. And then you've got another arrow that would connect. So like, you know, you've got this sort of like, I guess sort of like cyclical sort of nature to, I'm not sure how the arrows exactly work, but there's obviously some kind of logic here. Maybe it's more intuitive perhaps, but the idea is that you can define everything into categories. And so there you go, that might be some use, some insight. But the idea is, for this example, you know, this text area and this text area are technically two different types of text area, but they are both part of a larger system of programming languages. So if I let's see, I'm going to do it one last time to really hit a home run here. And I'm gonna copy this, and we're gonna copy this, and then we're gonna go another image. So we're doing well on the images. I will save this here. Save. I'm gonna call this HTML to JavaScript category theory. HTML to JavaScript category theory, aka the DOM. There you go. All right. So we'll create a new one, and we're gonna insert that image that we have. There it is. Nice. There we go. Here we go. And so what I'm going to do is like, man, the color coding. Oh, I really hope those colors were of use to people who are colorblind. Oh man, I'm going to have to see if I can open up. Can I open up two of these images at the same time? Dang nabbit. Let's see. Did I save it in the desktop? Let's see. I believe I'm going to have to maybe start all over. But anyways, the first color is, where's the blue? Let's look for the blue. This here is the blue. Right here. This is the blue. This is the DOM. This text area is the elements, so that's black. Then the, I guess this is also black. They're both the same. These two are the same thing. And then this text area over here, that's an equal sign, by the way. I can put, that's an equal sign, okay. This text area, this text area over here is going to be red. So, I mean, I'll put a star here. All right, there's a star there. I'll put another, I could put another star here. I'll put two stars over here. Like that. This one would be two stars over here. Like so. It's all right. Then you got this over here. That's supposed to be a star. Maybe I'll do, I can do like the pound star symbol star. Like so. And then the DOM, I don't think the DOM needs a star. I'll put a number here. The point is, you've got basically three components here that kind of tie it all together. You've got the HTML, which right now are groups of stars. You've got the DOM, which is going to be a pound symbol. And then you've got the text area, which is going to be a variable, JavaScript variable, and it is going to be the star symbol that you have on your phone. So this is JavaScript here. All right, and so technically all three can fit into JavaScript, the syntax, but they are not. It's not 100% pure JavaScript. It has the DOM, which is that tree, and then has the text area, or excuse me, it has HTML text that is going inside the JavaScript syntax. So that's pretty much that. If I go to the book again, not this book or not this page, but we go here, we're looking for some kind of function, right? And this is what this add event listener is all about here. So this, you're calling the variable that you've defined, and now you're using a method called add event listener that basically does a certain event to that particular element, right? And I think that's exactly what we're looking for. Now this particular event is called key down. There's actually a variety of key downs to choose from, or quote unquote key down, and then event da 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 da. Oh, my computer is low on power, so I guess I will charge it because we're not done yet. We're gonna have to add a little bit more juice, a little bit more electricity specifically, which is a flow of anti-electrons, flow of positrons. That is the direction of current, in case you were wondering. It is a flow of positrons, and positrons are freaking awesome. Check it out. So this is basically, you could tell that it kind of follows the structure of arrow functions, right? This is an arrow function. It's a function. So, the DOM has its own sort of syntax when it comes to functions, right? So this method, I believe, is calling a function. Now the question is, we need a specific function. We need one that's like either appear or disappear. Maybe that's what's going on here. This if statement here is telling you what event is going on here. F2 is obviously a key on your keyboard. So replace selection text area with case chemi. Case chemi. Event.prevent default. Not sure what this does, but it does something. We know that much. So we're gonna try to, maybe the easiest thing to do is just copy and paste this and try to follow similar syntax. So I think that's the easiest thing to do, but it's not the simplest. We're gonna have to make some modifications here in order for it to be simple. So this is, I'm gonna call this let's m1 n1 equal dom.getElement m1.innerHTML. So we don't have to actually do inner HTML because we're not really modifying the text. I don't think we want to modify the text. I think I want to make the whole, maybe I do want to make the text appear and disappear. There's different ways to approach this. I have to use the bathroom at the moment. I think this might be a good note. I'm going to keep the recording going, but if you need a bathroom break, now's the time. We're going to be efficient here, so like no more than like 5 minutes tops. No more than that. So, BRB. But like try to do it in like 2-3 minutes, and then I'll be back. All right, we're back. I think that was, it was about 2 minutes, 3 minutes. Pretty good. If you're with me, good job. Something else that can help your focus is having yourself a tasty snack. So I got myself this flavor called ula, and so I think the idea here is to stimulate a little bit of dopamine in your system so that you can come back and keep focusing. Because I'm talking, I don't think I'm going to suck on this too much. I will suck on that later. All right, so let's continue. Document query selector, text area. So yeah, we're trying to reverse engineer this. So let n1 n1, that's going to be our variable. Document dot get element by ID, which I believe it seems to me the same thing as query selector. I really don't know the difference. Now we could verify if it's different or not, but I don't think that's the most efficient approach right now. So we're not going to do that. But we're basically doing .inner HTML, which selects the actual text within the HTML, and that's what X is. I'm thinking that we're going to try to make the text appear and disappear rather than make the element appear or disappear. We don't want to actually get rid of the elements that we have, although we could do it that way as well. I think it's more interesting if we actually get the text to disappear or appear. Now you can let me know if that's like the most optimized approach or what your opinions are, like basically on some philosophical level, like do you want to focus on removing or adding the text, or do you want to focus on removing or adding the actual element in the HTML? Either way, I think both are going to be functional is the idea. So we're not, so this actual script actually adds the X into the, this actual command, the original one that I had, actually adds, oh, look at that. Wow. Hold on, I saw something, replace section, replace selection. Ooh. So this is the power of AI here. Text area selection, text area substring, 0, text area dot select star, text plus text area value. A lot's going on there. I mean, we can see what it does. I don't know what it does, so I'm not going to use it. But presumably, the AI effectively knows more or less what we're trying to do, or has some sort of understanding of what we're trying to do, even if it's not based on like raw intuition. It's again based on receiving specific input data, and it then proceeds to create algorithms, right? Yeah, interesting. So anyways, document.get element by ID, m1 n1.inner HTML equals x. So before I even use all of this, right, that's trying to reverse engineer here, I'm actually going to leave all of this as it is because we want those X and O's to be there, at least for the initial setup, because I mean that's what I got. But ideally, for a game when you're playing a game from scratch, you don't want anything to be there. So, anyways, here is let text area equal document query selector. I mean, maybe we do need to use some kind of function here. I'm trying to figure out how this works. Document.query selector text area. So I'm gonna call this m1 n1. Text area here, m1 n1 as well. Text area, text.area, add event listener, key down. We do not want to use key down. Event, if event, right? I don't know why this is red. That seems like it shouldn't. Oh, because maybe this variable doesn't exist. Nope, that's not why. Okay. It's actually still red. Oh, we're missing a bracket. I think that's why. There we go. And then I guess we need another parenthesis here. There you go. And we'll indent this here. I think that should be pretty good. All right, so we're going to do this one, m1, n1. And this is going to be m1, n1 here. Key down, So I don't think we're actually going to have any of this happening, so I'm going to get rid of this. Oh gosh, there's still some kind of typo here. Um, hmm. All right, so now we just got to figure out what the event. First of all, we got to change the event name. I know that they're specific. And then we are looking for creating an event. Now, I can put in pseudocode, which might be useful. Again, the software is trying to like figure out what we're doing. This is not what we're doing. I'm going to just simply comment this. And there's another way to comment in JavaScript, but basically, it's going to make text in HTML element disappear. That's basically the pseudocode. Oh, and then the event is click. That's good. Yeah, that's what we want. Make element disappear. So how do we do that? I'm assuming that there's some kind of built-in method here that's going to be like dot disappear, something like this, something like that. So let me see. We're going to Google search again. Add event listener. Make HTML text disappear. Now, we're probably going to get exactly the answer we're looking for because we have, I believe it's called Google Gemini. That is this AI overview. I'm not sure if this is Gemini or not, but this is like Google's primary AI, it seems. And it's already giving us answers. So I was trying to Google search like the way it's been done for like the last 20 years. But now if you Google search anything, you're going to get an AI result. So, that's how it is now. So anyways, click button to hide text. So we got paragraph, ID equals text to hide. Okay, I wouldn't call it that. It's a button. And we're not working with buttons. CSS is dot hidden. I don't know why it's dot hidden if I don't see the ID, or there's no class name here called hidden, so that's not clear to me. But display none, I'm not sure what's up with display. I thought that was for grid and flexbox. Document.getElement by ID, hide button. Add event listener, click. Okay, so hide button, let's see, hide button is this ID here. Okay, that's good. Document.getElement ID, dot add event listener, click function. Aha, you can create any function you want, that's cool. And then it looks like you got a function, you got a document dot get element ID within the function. Oh, look at that. Text to hide dot style dot display is none. Oh, okay, so you're basically creating another like HTML condition, presumably using CSS properties. Okay, that's not how I would do it. I just like create a blank space. But I see what it's trying to do. Function get element. Oh, okay, I'm gonna try another approach, but we're gonna stick to reverse engineering here because it may not be the easiest approach, but there is kind of a simple methodology here. So let's see here, but I think there's an easy quality to it, because you're just cutting and pasting. That's the easy part, but the hard part is that you actually have to modify it. But the simple part is that you're only modifying it, but the hard part is that those, or rather, there's a harder way of doing it, which would be to just do it from memory, from scratch, which would probably be in the long term, the probably the optimal way to do things. I know that senior developers have done it so many times because of experience that they kind of get it, they kind of have it memorized, right? So the question I think for the video, like a fundamental question here would be, is AI meant to help us do things more simple or more easy as far as programming goes? And I have reason to believe that it probably is, both. I mean, Occam's razor, which is basically the simplest answer is the likely correct answer, would suggest that it's both. But I think most of the kind of the community and so forth are focusing more on building things that make programming easier, like say vibe coding. But I believe that the best effective use of AI is to actually make things more simple, and that may be the problem right now with AI as far as programming, is that it's a little too. Oh, there's my alarm.
So let's see here. We're gonna wrap this up. I mean, we're in overtime now. But I will set a stopwatch just to see how much time has been worked here. Um, but I'm going to go ahead. I think I already pasted. Yes, this is exactly what we're looking for here. So document element ID hide button add event listener. Basically, that's what we're doing here, except we're doing it in 2 steps. We could do it all in 1 step if we really wanted to. We don't have to actually create this variable. But I think this is the question of like, again, O or E. But I think it, because of I think whatever saves you the most time and whatever is easiest to do for you is probably the most optimal. And as far as simplicity goes, it's probably more on the lines of how much energy you're consuming to do it. Both as your cognitive endurance, in other words, your time management, versus say the actual consumption that your computer is actually using for that particular set of commands. So we will leave it on that note. We've got click, we've got the function. So this is called event. I'm going to change this to function. And we'll just keep it old style. I don't have to use the arrow functions. To me, that is simpler. It doesn't actually, I think in this case, they're actually identical, simpler or easier. There's the pseudocode. Then we're going to have basically documents, get element by ID. I got it. This is going to be probably more leaning on the easier side than the simpler side, but I'm basically getting element ID M1N1. Or actually, I don't even think I have to do that. I think I just do document M1N1 presumably, because we have the variable there. And then I'm going to simply set the inner HTML to an empty space, like that. Boom, just a simple space bar. And then I'll comment this out. But that's my dot disappear. It's basically just creating a space. There you go. So we'll see if this works. I'm probably gonna have to do some modifications. I'm gonna comment this out. We don't need this. Oh, I'm gonna have to comment all this out. My comments are gonna be a little messy. And now I think we've got to save. Where is it? So we've got to save. Make sure it's saved. It is. Refresh. I click and nothing happens. Hooray. Not working. So this is now the next phase of programming, which is called debugging. Basically, you got to find the bug. So we have a bug here. It's probably a logical bug. It's not an actual bug, but it's a logical bug. So we have to figure out how we're going to debug this code. I thought maybe it's this here, right? I assumed that I could just use the JavaScript. Maybe I don't need to call it document because we already have the JavaScript variable there. Maybe if I get rid of this, we don't have to use the DOM anymore. Yeah, look at that turn blue. So presumably, if you're programming, you see color. It's still not working. Now, this is for M1N1, yeah. So let's see. Query selector M1N1. Maybe I gotta do get element by ID here. I'm not sure what query selector is, but we're probably gonna have to look it up if it's still. Oh, got it to work. So query selector. What is query selector? Probably, yeah, I would think maybe not the most effective, but at least not yet. But long-term efficiency definitely encourages us to look at what query selector is. It's the built-in JavaScript method used to access and manipulate HTML elements. That's what I thought. It searches a document for the first element that matches a specific CSS selector or a group of CSS selectors.
So I would think it would have worked with query selector, but it didn't for some reason. Document.query selector button. So yeah, so maybe it's the query selector might actually be for the name of the divs, not for the actual either ID or class of said div, and that might be the difference. And I think we'll go with that. So M1N1 is get element by ID, not get element by its proper name, basically. M1N1, so this is working. Make it disappear. Now I want to have another event where you click on it again and it reappears, because it right now it disappears. So maybe if I just like add another one. So this is definitely leaning more to the easy side than the efficient side. But as far as learning goes, I think it's pretty optimal. So I'm going to make that an X. Let's see what happens now. So now we've got more zing, more pop. No. We only got zing and pop, but we're looking for more zing, more pop. That's what we're looking for. So click function m1n1.innerhtml.x. Let's see here. X. Why didn't it work? Because, I mean, it's the same event. It's identical. The only difference is that it adds an X. That's the only thing I changed. Maybe like double click. Let's try like double click. Maybe we need a different type of event. So now what I'm going to do is I'm going to go to add event listener, event list, something like this, and we're going to try to see all the different types. Oh, so technically it's an API. This might be an API. Maybe. The method works by adding, so it is a method. Okay, that makes sense. Okay, it is an event. Add event listener is a method, that is. Okay, yep, look, it's got dot method right there. Okay, so we've got add event listener type and listener. So I'm looking for the list of types of add event listener types. I want to see all the types. So click obviously is like the most common one. This is just another syntax. This is the arrow function, but it's the same as this. They actually are identical, these two codes, logically. There's on click. Oh my gosh. So click is different than on click. That's what's going on there. If an event handler, for example, on click is specified to an element in HTML source, the JavaScript code in the attribute value is effectively wrapped in a handler function. Definitely going down, getting closer to a wonderland for sure. Now here's class something. Okay. This dot on click, constructor element, this dot on click dot bind, element dot add event listener click, this on click one. Interesting. So not really clear. Oh, look, there's double click right there. Nice. So this is a constructor, which I believe has something to do with classes in, say, JavaScript. Technically, JavaScript doesn't have classes in the Python sense, but there's basically the equivalent of objects. Excuse me, the equivalent of classes, which are basically, they're not anything like objects, sets, or arrays. They're more like, cousins to functions, essentially. They're more akin to functions than, say, akin to functions and methods than, say, oh man, I thought I had it. So when I reset, so the first click works really well. That's working like a charm. But the double click is not working. So maybe, yeah, we could create a class, maybe. double click. Oh, DBL, not DB, not database. There we go. One click. Oh my gosh. Two click, it appears. One click, it goes away. Two click, appear. One click, it goes away. All right, so it works. Again, probably not the, clearly not the most, what's this, the most simple, but it is easy, and I think it's optimal learning. So that's really what I'm looking for. Another question, what's the difference between efficiency and effectiveness? Ooh, could someone tell me? Oh, maybe I can do spacebar instead of double click like that. What do we do? We've 10 minutes in, you know, we could keep going. I mean, why stop here? I think rather than click, double click, I think I want to do like spacebar. Yeah, we're definitely cooking though. Double for now. I'll leave it at double click. All right, and then I think that's pretty much it as far as what I want to teach. For the sake of time, because of time, I think I want to wrap it up here. We could keep going. Okay. I was about to say I thought we lost all of this. We could try to add it to all of these, every single one, right? We could add it to every single one of these elements. I think for the sake of the information, let's just do the last one, right? Because if you remember that diagram I had, that diagram basically showed, if you remember, if you're staying focused, we got the 1 cross 1 for the first element of the matrix, and then we also mentioned the 3 by 3 in the matrix as the last element. We didn't really focus on all the others. The idea was just to have the beginning and the end, and presumably we can model the rest. So let's do that. Let's basically copy and paste this and do everything that we did, but for M3, N3. We're getting a little closer. M3, N3. M3, N3. Changing all this to M3, N3. And let's see if it works. This should be M3, N3 as well. And it should work. Oh, I gotta refresh. Oh yeah. Nice. We got it. I think the only thing we gotta do is just change it to purple. And then I think we can wrap it up. So what I'll do is we'll go to styles, which is a whole nother side of HTML. But this would be the M4 N1 of your header, which is the M2 N1 of your HTML. Right, so this is the HTML is a M2 N1 X. There you go. It's got to stay consistent here. We probably could get rid of all the X's, I think, at this point. It's kind of redundant information, isn't it? But anyways, we will go to style. We'll go to M3 and 3, and I'm going to go to call it color, and we'll make it there it was blue violet. And then what I also will do is go back to the script, and I'm going to make that was M3 N3. I'm going to add a star to this. I'm going to add a star to that, and then I'll add a star to this one as well. And then we'll go back to styles. We'll go to M1, N1, and I stay consistent here. Color, it's going to be blue violet right there. And if we refresh, oh gosh, didn't work for some reason. I forgot the colon, semicolon. That is. Oh gosh, I changed. Oh, that's why. That was the M1 N2. Let's go M1 N1. So that was not very efficient, but should be effective now. Boom, there we go. And so this is, again, just a gentle reminder that we're talking about the old style way of programming, which has been around for a long time. You know, it's definitely been around since at least the time of turning. And if you click once, it disappears. Click once here, it also disappears. You double click up here, it reappears. Oh, but it reappears as an X. What color is the X though? Why is it blue? Oh, okay, it's a purple X. There you go. Nice. So they should also have stars technically. I think we should, yeah. Let's see here. So this would be a star here. This would be a star there. Refresh. There you go. There you go. Not bad. Not great. Not bad. And I think on that note, thank you so much for watching the video. You know, again, I'll see you all in the next one.